Water resources are not evenly distributed around the world. Some places lack sufficient natural water sources and need to find various alternatives. Desalination is a technology that desalinates seawater. It is the only alternative water source in many parts of the world. There are two main desalination processes, namely thermal method and membrane method. The core technology of the latter is reverse osmosis technology, which is the most common technology today. To understand what reverse osmosis, we must first talk about osmosis. Osmosis is actually a very common physical phenomenon. Suppose there is a pool, separated by a material called a semi-permeable membrane. Solutions of different concentrations are injected on both sides. In the absence of external energy and pressure, water will spontaneously diffuse salt concentration, higher concentration through the semi-permeable membrane. The liquid level on the salt water side will also rise, until the concentrations on both sides reach equilibrium. This process is also called forward osmosis. At this time, if we apply a certain external force to the side, with higher salt solution concentration, the water molecules on this side can pass through the semi-permeable membrane, making the salt concentration on the other side further reduced. This process is called reverse osmosis. This technology was first used commercially in the 1970s. Today, this technology is used to extract tens of millions of tons of fresh water from seawater every day around the world. How does a desalination plant work? First, we need to set up a seawater intake, mainly in the form of surface open intakes and beach wells. Surface open intakes can collect larger water flows and are the first choice for large desalination plant. But the disadvantage is that the water quality may be affected by turbidity, temperature, seawater discharge, or storms over time. Beach scenic water, which can provide better and more stable water quality, benefits from the natural filtration process underground. In any case, water is pumped. These pumps can be negative pressure pumps located on the sea surface, or submersible pumps in the sea. When using submersible pumps, seawater flows into the pump through the gap between the pump impellers, and is then radially propelled by centrifugal force. These impellers are connected to a single shaft and driven by an induction motor. By alternating the impellers and diffusers, the pressure in the shaft is gradually increased. Finally, sufficient pressure is formed to deliver seawater to the site. The seawater must be pre-treated, and the specific measures depend on the type of intake and the characteristics of the seawater. The first step of pre-treatment is most commonly filtration, by using matrices of different particle sizes. Most suspended solids with a particle size greater than 20 microns can be retained. Over time, these filters will become dirty. Efficiency will also decrease. Therefore, regular backwashing is necessary. With the development of technology, the amount of chemical used in reverse osmosis has been reduced a lot, but to ensure improved recovery rates, many plants still add anti-scaling agents in advance to prevent salt precipitation in the membrane. The filter cartridge filter is an additional device installed between the pump and the reverse osmosis membrane unit. These filters can retain particles of 1 to 5 microns, reducing the damage of these particles to subsequent processes. After pretreatment, the water can enter the module assembly. Sufficient pressure needs to be applied here, usually 5 to 6 MPa to effectively treat. Therefore, a high-pressure pump is used. What you are looking at now is the reverse osmosis membrane unit, which is the core of the desalination process. The system consists of a series of FOP pressure vessel membrane housing assemblies, each of which has several membrane modules. Usually 7 membrane modules are connected in series, and the water molecules are forced to pass through the membrane tangentially by applying pressure to the incoming water. This is the reverse osmosis process. 40% to 45% of the water passes through the membrane surface as permeate and enters the finished product collector. This part of the water has only a very small amount of salt, because up to 99.98% of the salt is retained on the other side of the membrane. This water containing a lot of salt is called concentrated water, and the proportion is about 60%. In order to reduce the total energy consumption of the desalination process, the desalination plant will also set up an energy recovery system to recover the energy in the form of pressure in the concentrated water. Among the various recovery systems, the most commonly used is the system based on the isobaric design. The potential energy in the form of pressure is transferred from the concentrated water to the same volume of seawater. The efficiency is over 95%. The seawater leaving the energy recovery device and the seawater leaving directly through the high-pressure pump need to use a booster pump to pump additional water because of the different pressures to balance the inlet pressure of the true water inlets entering the membrane assembly. After the concentrated water passes through the isobaric chamber and the pressure is released, it leaves the energy recovery device at low pressure and is discharged into the sea. The water plant will adopt the correct dilution and distribution mechanism to ensure that the discharge does not affect the marine ecosystem. The desalinated water also needs post-treatment because this water is corrosive. It must be remineralized to achieve a balance of pH, alkalinity, and calcium content. Ensure that the water quality remains stable during the subsequent distribution process. Among the several mineralization technologies, the most commonly used are carbon dioxide injection and the use of calcite beds to add calcium carbonate to the water. This adjusts the pH value of the water and increases the hardness and alkalinity of the water. If this water is ultimately intended for human consumption, also needs to be chlorinated to ensure that the effluent meets relevant hygiene standards. Finally, through the water supply network system, the desalination plant transports the clean effluent to farmland, factories, or every corner of the city.